This is instruction on how to do dimensional analysis. I'm going to do example 1, 2, and 3 with you, and then the rest of the questions on the homework are for you to practice. Example number 1 says riders have to be at least 48 inches tall to ride a roller coaster. What is 48 inches in feet? I'm going to first show this as a proportion. And in the proportion, we're using what I have always called the original recipe, and then the 48 inches would be the modified amount. So if I set that up as a proportion, it would look like this. And you would cross multiply, and you would get 4 feet. This is how you set it up with a proportion. And what the presumption is with proportional reasoning is that you are creating a proportion with known information and then setting that equal to your unknown information. Now I want to show you what it looks like with dimensional analysis. In dimensional analysis, there are two things that you always have: the given number and the conversion factor. This information will be the same thing that you use in proportional reasoning, except for you're going to set it up in a slightly different way. The given number will always come from the question. It's the unknown value, the modified recipe. The conversion factor is the known information, the original recipe. The idea behind dimensional analysis is that all units can be converted to other units using conversion factors. So here's how you set it up. Start with the given number and label it with what it is. So my given information is 48 inches. Then I multiply it by the conversion factor to convert from one unit to another. In this case, I'm converting from inches into feet. When I set up my dimensional analysis problem, the goal is always that the inches will cancel out with the inches in the conversion factor. So if I set this up correctly, I will put 1 foot on top and 12 inches on the bottom. Imagine for a moment that I just increase this division line like this, and you might be able to more clearly see that the units on the top are canceling with the units on the bottom. It is the same thing that gets done with proportional reasoning, except for that this way in dimensional analysis has already quote-unquote been cross-multiplied. So it eliminates a step in proportional reasoning, and it allows you to do more work with the number, which we'll see later on. Then to do this problem, you have to multiply and divide. The order in which you do that does not matter. I prefer to always multiply first and then divide. So let me highlight the path of my multiplication and division. I'll multiply 48 by 1 and then divide by 12. And if you do that, you end up with 4 feet. Let's look at number 2. How many moles of aluminum are in 5 grams of aluminum? For this problem, we're going to pick the setup that is correct, and then we are going to calculate. The way that you can tell what is correct is by looking at the unit cancellation. If I extend my line, kind of like that, where my 5 grams is on top, I can look at how the units are canceling out. In A, the units are not canceling out. So if you solve this problem, the ending unit result will be grams squared over mole. Whatever you do to the numbers, you have to do to the units. If you multiply two numbers together, like here with the same units, then the units get squared. If I look at B, if I multiply all of these together and divide, my gram units will cancel out. Just like how if you have 3 over 3, that gets you 1, and the 3's cancel out, you can do the same thing with units. Being able to cancel out units is also a really nice way to check that you've done the right thing. And if you don't really know how to do the problem, but you can get away by using conversion factors, you'll often get the correct answer. So for B, the ending unit is moles of aluminum. That is what the question's asking for, how many moles? You'll realize that anytime a dimensional analysis problem is set up correctly, the unit that you're looking for is on the top, and the unit that you start with is on the bottom, every single time. It makes setting up these problems a little bit quicker and simpler than doing a proportional reasoning problem. So we now know that B is the correct answer. And if you do the math, 5 times 1 divided by 27, you will get 0.19 moles of aluminum. It's important that you label with what it is, because in the future when we do more complex problems, knowing what it is becomes essential to setting up the dimensional analysis problem. Let's look at number 3. Earth takes 1 year to orbit the sun. Use the given conversion factors to calculate how many seconds the Earth takes to orbit the sun. Now we're adding on more conversion factors. Unlike proportional reasoning, where you have to set up multiple separate proportions to do something like this, in dimensional analysis, they just stack up next to each other. Another positive to using dimensional analysis. In dimensional analysis, you always start with the given information, and then the first step is to convert it into the next unit. Here, I'm trying to go from years to seconds. There's no direct conversion here that I have from years to seconds, but I can go from years to days, days to hours, and hours to seconds. So let's do the first one. First one is 1 year to days. If I do this correctly, then I'll do 365 days over 1 year. Check that my units cancel, year cancels, and now I'm at days. The next is to go from days to hours. In order to get from days to hours, I need to cancel days out. So I put that on the bottom, 24 hours on the top. Again, my days will cancel and I'm left with hours. Last is to go from hours to seconds. I want to end up with seconds. So I'll put that part of the conversion factor on top and hour on bottom. Hours and hours cancel. Now what's left is to do the math. So to do this math, I'm going to snake my way across, and I'll show you what that looks like. You are free to do the multiplication and division in any order that you want. Multiply all the top, then divide by all the bottom. Or do all the division first, then the multiplication. It doesn't matter. I, however, like to snake my way through so that I don't miss any of the numbers. So what I mean by that is I go from top to bottom, top to bottom, top to bottom. I go 1 times 365 divided by 1 times 24 divided by 1 times 3600 divided by 1. So I've made sure that I've hit every conversion factor in my calculator, and I'll end up with 31,536,000 seconds. All right, you should be able to do the rest of the problems. Please make sure that you are answering every question using dimensional analysis. Of course, you can use proportions here. There's nothing that we're learning that's necessarily new, but the point here is to practice dimensional analysis because this way of doing problems is a superior way. So, try and learn how to do this.